In problem 1, we're asked to determine the behavior of this function, and we're given this picture on 1, 2, 3, these 4 intervals, and what happens at these 3 particular values. So, what do we know about the derivative, right? Let's take a look. We'll just go straight across here if we can. What do we know about the derivative on this interval? So here's the interval here. Look at this function. It's decreasing. So the derivative is negative f of x. Well, we're just giving a blank right there. We don't know the exact value of f of x because there's infinitely many points in there. But this function here is decreasing on that interval. Now, what about right at 6? So if we come over here to 6, it looks like, well, the derivative, that's the slope of the tangent line. Looks like we have a horizontal tangent line there. So I'm going to claim that the derivative is 0, and it looks like the function value, well, we're told that the function value is 3.9. And then just by the graph, looking at 6, the function is decreasing, hits a minimum, and then it's increasing. So what we're going to have is a relative minimum, but not only a relative minimum, it's also an absolute minimum. It's relative because relative to a little interval around that 6, that point is minimum, but also it's the very smallest one on the entire graph, as is this one. Now, what happens in this interval here, 6 to 8? So in 6 to 8, looks like the function's increasing, and because the function's increasing, the derivative is going to be positive. No particular value here, so we'll just say the function's increasing right there. Now, what happens right here at 8? Well, at 8, if I'm looking for the derivative at 8, we've got a corner here. There's no derivative. There's no individual unique tangent line. So what happens right here is that this is undefined or does not exist. So what we can write here is that the derivative at 8 does not exist, but it looks like the f of x value, and we're actually given that one, that's a 9, and it looks like this is a relative maximum. Right? It's a relative maximum because relative to a little interval around 8, that is a maximum point, right? In this interval here, near 8, relative to 8, we get a maximum. Now, from 8 to 10, that function is decreasing, so the derivative up here is negative, no particular value, so the function looks like it's decreasing. Now, right here at 10, okay, right here at 10, okay, again, look at that, look at f prime, right? We're trying to get f prime. We got a horizontal tangent here, and slopes of horizontal lines is 0. The value here, well, we're given that's a 4.1, and you can see that around 10, near 10, relative to a little interval around 10, that's going to be a minimum. So this is like what we had at 6. What we're going to have here is a relative minimum, but also an absolute minimum. And then finally, what happens out here in this interval from 10 to infinity? Well, it looks like the derivative, the function's always increasing, so the derivative is going to be positive, no particular value, and we get an increasing function.